In this video, I am going to prove using the epsilon delta definition of a limit that limit of 2x plus 1 as x approaches 1 equals 3. First, let's recall the epsilon delta definition. We say that limit of f of x as x approaches a equals L if for every epsilon greater than 0, there exists a delta greater than 0, such that absolute value of x minus a is in between 0 and delta, then absolute value of f of x minus L is less than epsilon. So our job is to match this definition with our function. 2x plus 1 is my function, so I call it f of x. 3 is the value of the limit, so this is L. 1 is the value that x is approaching to, so 1 is A. Hence, f of x is 2x plus 1, L is 3, A is 1. So we need to show that for every epsilon greater than 0, I can find a delta greater than 0, such that 0 is less than absolute value of x minus 1 less than delta. Then, absolute value of 2x plus 1 minus 3 less than epsilon. This is the exact statement we must prove. Step 1, we'll start with the epsilon. We'll let epsilon greater than 0. Now, we need to find a delta. So we are working backward here. We need to work on the absolute value of f of x minus L less than epsilon. F of x is 2x plus 1, and L is 3. So I am going to replace f of x with 2x plus 1 and replace L with 3. And I want the difference between the function and L less than epsilon. Now I am going to simplify this expression until it's in the terms of absolute value of x minus 1. So first, I need to drop the parentheses. So I have 2x plus 1 minus 3. And if I combine like terms, positive 1 minus 3 is negative 2. From here, I am going to factor the 2 out. Now, since 2 is a constant, so absolute value of 2 is also 2. So I can take the 2 to the front. And now I will divide both sides of this inequality by 2. 2 divided by 2 is 1. I stop here because I have absolute value of x minus 1. Absolute value of x minus 1 is less than epsilon over 2. This tells me exactly how close x needs to be to 1. So now I choose delta to make that happen, and a simple choice is epsilon over 2. Also notice, because epsilon is greater than 0, and my delta is epsilon over 2, so my delta is also greater than 0. I chose delta equals epsilon over 2, and I have to show that this choice actually works. So let's verify the definition. I have 0 less than absolute value of x minus 1 less than delta, I will replace delta with epsilon over 2. Now, if I multiply everything by 2, I have 0 less than 2 times absolute value of x minus 1 less than epsilon. Now, this 2 is a constant. I can also bring that inside the absolute value as well. And I need to distribute the 2 out. And negative 2 can also be written as positive 1 minus 3. And I end up with the absolute value of f of x minus L less than epsilon. And that is exactly what the definition requires. So for every epsilon greater than 0, if we choose delta equals epsilon over 2, then whenever x is within delta of 1, the value 2x plus 1 is within epsilon of 3. So we have proven the limit. So let's write our conclusion.